Romexpo, aici o să aibă loc evenimentul DevTalks. Dacă mă urmăriți, deja știți despre ce este vorba. Am făcut și un giveaway pe canalul de Instagram în trecut. Mă gândeam să vă iau cu mine la eveniment și să vă arăt așa câteva cadre despre cum stau lucrurile aici, care este atmosfera, cum sunt standurile amenajate și mai ales care sunt speakerii și despre ce o să vorbească. Sper să vi se pare interesant, mai ales dacă n-ați putut să ajungeți la eveniment, având în vedere că se desfășoară pe durata a 2 zile în cursul săptămânii și abia aștept să vă arăt și să văd și eu totodată ce se întâmplă acolo. Haideți!
Provided form, show spinner and update UI, and on the background, okay, so at this moment my main thread is blocked. Just after update UI it's not blocked anymore, okay, and I create a new task thanks to set timeout to save database and set analytics, okay. But be careful, because if you do that a lot of time in your application, set timeout don't care on which arrived in priority in the task queue. So if you do that a lot of times, maybe you can have some problems like desynchronization of your application, okay. This is due thanks to the event loop. This is how it works. That's why we create post-task API, to avoid that.
As I said, when you want to develop in clean architecture, you are focusing mainly on features. One of the most used features in the literature is the authentication feature. So here you create a folder called authentication, and based on the diagram that you saw before, we have data, domain, and presentation layer. The presentation layer is what the user sees, and also where we add the state management solution. The data layer where the data is coming from, and the domain layer is the one that dictates how the data in the presentation layer should work. And mostly everything starts from the domain layer when you imagine what you need to do. So for an authentication system, we have some use cases. We need the user to log in, to register, and to, I don't know, recover password or get user data. So each function that we detail, we create a specific file for it. We have here login, for example. And this structure here will act as a contract. Yeah, the domain layer should not be changed in time. So basically, the domain layer remains the same. If I want to get the same authentication feature in another application, but to just use the backend, the domain layer will remain untouched, but we just need to change the data source. So here we see that we have a class, with some parameters that we are asking for the user when it logs in, like email and password, and then we have this authentication repository, which dictates and contains the login method here, which is basically an abstract class. When we want to do an implementation of the authentication repository, will be highlighted that we need to implement these methods. So the repository folder, and also we have, sorry for the login system here. Let's see what we have. Also we have the user entity, which is basically a model, an abstract class for the model, a contract for the model, that is containing the minimum necessary data for this use case to work. And you will see that also in the data layer, we'll be having the user model that is implementing the user entity, and we do like this. We add the user model into the data layer because the conversion method, for example, can be different from data source to data source. So again, we have the login that implements the authentication repository, and in the authentication repository we have the contracts, we have the login method that needs to be implemented, register, and get user details. Also, in some cases, we have like this type of data use cases, or we have some resources that needs to be spread and used by multiple features. So for this, oh my god, for this we are using the core folder when we can share together the data or the classes that we want to reuse by other features as well.
this generative AI technology is able to not just give you a simple output. They give you conversational text, they give you images and videos and music and so much more. So this is the power and this is why it has spread so quickly. But in order to understand generative AI, we have to start with the overview of artificial intelligence. And artificial intelligence is basically anything you try to do to make your computer act like a human. So using if-then statements and all those machine learning models just so you get an output as you will get from another human being. And the subset of artificial intelligence is machine learning. And with machine learning, you can use these models to detect some data, repetitions and patterns and build some sort of logic and then reusing those models for other data sets and so on. If we go deeper, we have deep learning, another subset of machine learning. And these models are more complex than the machine learning models because they have these multi-layer components and they can, for example, perform things like image recognition or speech recognition. And if we go even deeper into these technologies, we have generative AI. And these models are trained on already billion or trillion of parameters, and this is why they are able to act as a human and give you more complex responses to your questions or your prompt engineering about generating a new image and so on. But I think to summarize it better is if we take a look at this graph. So basically if you look at the machine learning, you have a simple input and using something that an algorithm, it will give you a simple output. For example, predicting a number, a true or false, or the next number in line. That's a simple output that any machine learning can do. If we look at the deep learning, for example, then you have a more complex input, but the response you get is still simple. It's a simple output. For example, you can give it a picture and ask to identify if there is a cat, right? But that's a simple output. We'll say yes or no. With these foundational models for generative AI, you can detect many more things. You have complex inputs, but also complex outputs. So this is the big difference, and this is how generative AI actually works and why it brings so much value to the way we work today.
But before starting with the content, I would like to understand who is in the audience. Any engineering managers? Okay. Any people who consider this role or would like to try to see how it goes? Okay, good. Thank you. Any managers of managers, maybe? Okay, good. Developers? Yes, okay. So you want to see how are the things on the other side? Okay, I understand. Okay, great. Thank you for sharing this. So I will start from this trident model. At the beginning of my career, I was not so aware about the fact that I could go in multiple areas. 10 years ago, the engineering management area looked like a promotion. Now, it's more like a lateral move. So you have multiple options when you work in programming, when you are a developer. So this model is inspired by Pat Kua, and he said that somehow there are three different areas. It's this management area, where you are working on management activities, everything related to people management, product management, and so on. And here are roles like engineering manager, VP of engineering, IT manager. You have the individual contributor path, and here it's about more executing or doing. You are a specialist on something, you are a DB specialist, you are maybe a backend engineer and you are very focused on that, you are a full stack engineer and you are focused on that. And it's also this path, technical leadership. When you are more than a developer, you are also driving the technical topics for your team. Today we will focus on the management part, but it's important to know that all these three paths are valid, they are possible, and it's a choice. Sometimes you could also experiment each one of them to see which one matches your expectations, but sometimes it's important to focus on only one if it's clear for you that path. Okay, so the engineering manager. I say that it will be like a mind map today. This is the route. Then we will focus on three big areas. I see this engineering manager role like a product management area, a technical leadership area, and people management. They're very useful. These two are somehow the basics in the product management area. We don't need to be product managers by default, but for sure it's very helpful to cover these items, be aware about them. And the sprint book is very relevant for when you want to experiment ideas. It's a sprint of 1 week, and by the end of the week you need to have, or you will have a prototype to test in a fast way the idea or that feature. And it's an entire process that it's very well described.
Time was short, but I think that in the slide that the Q1 that I gave you at the beginning, there are these resources to become an architect. And the key takeaway, action, evolve your architecture. Don't blindly follow what some textbook architecture. Look at your pain point and evolve, gradually implement, and try to play this refactory groups with your team so that everyone knows what to do when the pain strikes.
Spre deosebire de ziua de ieri, când prezentările s-au axat mai mult pe partea de web, mobile, Java și așa mai departe, astăzi vor avea loc cu totul și cu totul alte prezentări. Avem o dată gaming stage, security stage, DevOps, QA and testing și așa mai departe. Vor fi lucruri foarte interesante și pe zona asta și abia aștept să văd despre ce vor.
Paradigm of the CIA chemical. As Sulu puts it, if my system is distributed, why do I need to worry about my availability? If my system is immutable, why do I need to worry about my integrity? And if my system is ephemeral, why do I need to worry about confidentiality? So this is the part of the talk where everything goes wrong. I've got a small demo. I'm going to show you how to design something related to the DIE track. So I've got the system where I have VMs which are running Docker containers in them. Why running Docker compose? Because I'm doing a simple website. Because I'm using a simple website, I don't need Kubernetes and complexity of Kubernetes. So I've got a few VMs, I'm running it on the version because it's cheap, but you can run it on anything you want. Google Cloud, any cloud provider, or a cloud. Everything is done in code, so I'm using Terraform and Packer to build my images. And as I said, I have distribution by ensuring that I have multiple VMs. I've got about 10 VMs. And what this does is basically I've got this site running the influence. This is my travel log where I post where I want to go, where I have been, I put some photos. It's a very simple website. I try to look at React. My front end skills are useless, but I think it's not too much. So this is what's running. And I'll show you a little bit of code. I don't mind showing code during presentations because you can go and look at GitHub people if you want to. But basically, what you want to see is what done. I'll show you the setup. So this is a packer. This is a bash script which basically runs with a packer. I install Docker, certificates, blah, what is included is this. So with Intron, what Intron does is it allows you to look at changes within files. So as I said, I'm looking at changes, but my system is immutable. So changes shouldn't be happening. So Intron looks for changes. What I do is I tell it if a change happens, run the shutdown script. As you might guess, the shutdown script is shut. So it's basically saying if password.txt is touched, then I create password.txt is completely empty. I just fill it with whatever. Doesn't really matter. So if the password.txt file is touched, run the shutdown script. So let's try this out. I've got port 22 open. Obviously for demo purposes, so I go in. Yeah. Hopefully it's working. Yeah. Also accept the fingerprint. I want to get in. It's my there you go. Yeah. Come on. Let me in. Cool. Awesome. I'm in the system. So I'm running. I've now got into one of the servers. Let's look around what that is. The bash RC, Docker file, SSH, passwords.txt. That would be very interesting for anybody. So let's cut it out. Let's see what passwords we have. Open this connector. But it's gone up. Well, what happened is the VM shut down, literally. Disabled itself. Because it saw that somebody touched the file, shouldn't be touched, and shouldn't come. And my site is still up. So, okay. Fairly simple tip, well done, extremely easy site. It's all nice and easy. This was designed from start, from scratch, and I do have statefulness with a database. But obviously, you can get the system. And in fact, I have subsystems which are stable, which shouldn't be stable. And I have some systems which are not really immutable because I SSH them. So how can we get into a more DIE way of doing this? Well, this is where chaos engineering comes in. Or creative destruction, basically. Because chaos engineering shows us what we actually know about the system. And do we actually understand how the system works? It shows us how things will happen when the unexpected happens. When a DDoS attack occurs, how will my system react? Part of requirements for chaos engineering is observability. We need to have good observability to ensure we're doing good chaos engineering.